In this video, we are going to do a review of user-defined data types, in particular the struct data type, and we're also going to introduce using this time.h header file just to help us create a deck of cards. That's going to be our user-defined data type is a card, and hopefully this will help us as we do a handful of programming exercises throughout the semester. So what I have here is just my basic blank getup for starting a program in Visual Studio. I almost always am going to be dealing with the input-output stream, so I have include IOStream. Just for kicks, I have include string. You need that quite frequently, but the one that's probably new to you is this #include time.h. So anytime you want to do anything with generating random numbers, which we might want to do if we're thinking about trying to shuffle a deck of cards and pick kind of a random deck, a random card in the deck, we might want the ability to generate random numbers, and in order to do that we need this time.h header file to be included, so make sure we've got that in your header. Now what we're going to do is we're going to do a user-defined data type, which is a struct. So the keyword for that is struct, and it goes up here where function declarations go, but we're also actually going to do this sort of definition of the struct before we get into main up here. So just we type in the word struct, and what kind of struct is it? It's going to be, we're going to call it a card, so we give it a name. And we've got these brackets, open brackets and close brackets, just like we're defining a function. But a big key difference that you want to remember is that we have to end our struct definition with a semicolon. So make sure you've got that there, or your program won't do what you want it to do. And for us, we're going to think of a card, like we would see in a standard deck of cards, as having two attributes. It has the number that's on the card, and it also has a suit. So we're going to view the number as an integer. We're going to give it an integer number, and a card is also going to be a character, which is its suit. And for us, this is going to be our struct. Just two things thought of as one. A card has a number and it has a suit. So now when we get into main, let's write a little bit of code that's going to create a whole deck of cards for us. Now my computer is a standard Windows computer, and it just uses the ASCII character code, and this could differ if you have a different type of computer. Particularly if you're using a Mac, this isn't going to be true for you. But if I go to the console screen and I see out character value of 3, so take the integer 3 and convert it to a character and show me what that means. If I were to type this in and hit compile, it's going to show me a heart. Now 4 and 5 and 6 also give me card suits, so I think 4 gives me diamonds, let's see, yep, and spades and clubs are going to be the other two in some order. So those are the characters that I'm going to want to assign to my cards, and it's just going to make it so that I can display a card to the screen as like a 4 and then a club symbol. So 3, 4, 5, and 6, those are my special characters for using for card suits. And for numbers, what I'm going to do is I'm going to have the numbers 1 through 13 for the cards in my deck. I'm going to think about as 1 as being an ace, and I'm going to think of those 11, 12, and 13 as being my jack, queen, and my king. Everything else makes sense? So let's go ahead and build a deck of cards. So what I want is an array of 52 cards. So just like I'm defining a normal array, if I were defining an array of integers, I'd write integers and then name my array of integers and then tell the computer what size I'd want. I'm going to do that here, except the thing that I want to make an array of is a card. I want an array of cards. So I'm going to have an array of cards called deck, and I want to have 52 of them. And then I'm going to write a little for loop that initializes them. And I'm going to cheat a little bit. Instead of stepping through and doing 52 things, I'm going to do all the suits at once. So inside my for loop, here's what I'm going to do. I'm going to start out by taking deck at I, and deck at I is an individual card, and a card has two things. It has both a number and a suit, and I need to initialize both of those things. So the way that I go ahead and initialize them, or in fact access those individual attributes like the number and the suit at any point in time during the program, is I use this dot notation. So if I want to access the number part of a card, deck at I is a card, and if I want to get to its number, I hit dot And you can see my computer's trying to tell me it's either .number or .suit. Those are the two choices I have. So decadi.number is going to be equal to not I, but I plus 1. So I'm writing in computer speak, and people don't want to see the 0 when we start counting. So decadi.number is going to be 1 more than the I value I'm on. And decadi.suit here is going to be my smallest value. It's going to be the character value of 3. And that's going to give all my hearts right away. So what I have in this bit of code right now would establish not the entire deck, but the bit of code that I have right now would establish just the hearts. Now, instead of doing 4 different for loops of this nature, 1 for hearts, 1 for diamonds, 1 for spades, and 1 for clubs, I'm going to do them all within this one for loop. So the first 13 cards in my deck are going to be my hearts, and then starting at the 13th position, so decadi 13 over from there, I want to initiate the number to be the same, starting with the aces, I plus 1, and then going up through the kings. I want to make the 13th card in my deck, and then the 14th and 15th and 16th and so on. I will make their number the same, so they go up ace, 2, 3 all the way up through 13, but I'll make the suit at this position a diamond. And similarly, I'll do decadi plus 26, so after I lay down the 13 hearts and the 13 diamonds, let's go put the spades in here. So the numbers will still be the same, but the suit, again, will shift over now to be a character value of 5. And decadi plus the next set of multiples of 13 is going to give me 39. And decadi.suit will be a character value of 6. Oh, not decadi. Needs to match. Decadi plus 39. So this little chunk of code right here, create an array of cards, 52 of them, and this code underneath it initializes the deck. Now right now I'm going to compile. Nothing should happen because I haven't chosen to print anything or do anything other than just compile. Nothing I would know about. But I am going to compile just to make sure I haven't made any silly errors. I like to compile every now and again to kind of chunk what I'm doing together for debugging purposes. So I'm going to compile this, and it did compile and I didn't get any error messages, so that's a good thing. But now let's see if this actually did what I wanted it to do. So let's come up with a way to print a card to the screen. So it is the case, we now know what a card is, but one particular card I could say card, this card, which is the deck at position 0. That's one thing I could do, is declare a card to be this card. With an integer, if I wanted to see an integer, if I have integer, this integer is equal to 5, I can say cout this integer, and then the line is a lowercase, and I could compile this and it'll print 5 to the screen, the value of this integer. And there's no problem with that. If I try to say cout this card and end the line, the computer kind of underlines those squiggles there, indicating that something bad is going to happen. And if I try to debug it, it says, there are build errors. So even though a card is a data type that I've defined, because I've defined it, C++ has no idea how to print this out to the console. So I'm not allowed to do something like this. So anytime I create my own data type, I'm going to probably have to build myself a function for printing it out to the screen if that's something that I'm ever going to want to do. So let's go back up to the top. We don't need this stuff at the moment. It's just for example purposes. Let's go back up to the top and let's create a function. It's a void function because it just does something. And let's call it printcard. And what does it need? It needs a card called this card. So we'll pass a card to the printcard function, and then we'll write a function that actually displays that to the screen how we would want to see it. So we're going to define it up here before we get to main, or we're going to declare it up here before we get to main, and we'll go down outside of main here to define our function. So what's it going to do? Ideally, what it would do is it would print out to the screen this card dot number. Remember, that's an integer, so it has no problem displaying that to the screen. And then it would print out this card dot suit. Then end the line. So this could be a preliminary attempt at printing out a card. But remember, this might not do exactly what we want it to do. So let's see. Let's write a little for loop. For integer I equal to 0, I less than 52, I plus plus. Let's write a loop that goes through and calls this print card function of the deck at position I. And what this should do is print all of our cards to the screen. So I go ahead and I compile that, and it does. Remember, we did all the hearts first and then all the diamonds, so it goes 1 through 13 with hearts next to it, 1 through 13 with diamonds, and the others. So it really did print us the whole deck, which is nice. Oh no, it didn't. It did something sort of funny. So let's see, it did all of the hearts, 1 through 13, it did all the diamonds, 1 through 13, and then it started counting by 2s for the clubs, so I must have had a 2 somewhere where I didn't need to have one, so let's go back and find it. And that is perplexing, because I do not see that error there, but clearly it's happening. This card dot number, this card dot suit. That is entirely perplexing. So on that third set, it doubled everything instead of, I see it. Wow, that was really hard to see on this type. I wrote I plus I, not I plus 1, and I just couldn't see at first glance that that second I was an I instead of a 1. So if I go back and I fix that, now everything should be printed really nicely. So there you go, folks, live mistake. This is why we write functions to check our work. And now we go back and we look and it's actually printing correctly, which is what we want. Well, it's almost printing correctly. It prints for what I did correctly, but remember, we want to make our programs user-friendly. So if I'm really thinking of the 1 as an ace, maybe instead of a 1 I'd like there to be an A there, and maybe instead of 11, 12, 13 I'd like to see a jack and then a queen and a king, even though internally I'm going to think about those things as being 11, 12, and 13 to preserve the ordering, this natural ordering that we have on the deck. So that's what I'm going to do. I'm going to make my print card function a little bit fancier. I'm going to come down to print card, and I am going to put in some if statements to check the number on the card. And if I have an ace, jack, queen, or king, I'm going to print out something different than this card dot number in the spot. Otherwise, I'll print this. So let's come up here and let's say if this card dot number is equal to 1, then in that situation we have an ace. So what we'll print to the screen is the character A and then this card dot suit. Then we'll end the line. Otherwise, if this card dot number is 11, then we're looking at a jack. So we'll print out jack of this card dot suit. The next option is that we could have a queen. That would be a numerical value of 12, and in that case we will print out queen and end the line. And our last else if case is if this card dot number is 13, and that's a king, so we'd print out king. And then our last statement is just otherwise. That's everything else we could possibly have. Then we'll just actually print out the number with those 2 through 10s. So here's a little bit of a fancier print card function. So we've changed the print card function, but we still have that call in there. Let's see what happens when we compile now. Check for errors. And we'll see it did what we wanted to. It changed the 1s to aces, changed our jacks, our queens, and our kings, and kept everything else the same. So there we have it. We've defined our own particular type, which is this card function, and we've figured out a way to print that out to the console. And in fact, we figured out a way to print this whole deck. It may be useful actually if you're going to be building arrays of your own user-defined data types to put this particular chunk of code into a function. So for example, I've got the print card function, but maybe I'd want to do something like print deck function that gets handed an array of cards and then just does this little for loop process for you. That's not really a necessity. The very last thing that I want to do in this video for you is show you how to use that random number generator that I mentioned way at the beginning. So let's go ahead and do that. So in theory, if I'm doing something with cards, I want to have the ability to shuffle my cards. So here I'm going to comment this out. I'm not going to print all the cards to the screen anymore. Let's just comment that out for now. Let's pick a random card to print to the screen once they've all been initialized. So the very first thing that I need to do if I'm going to use the random number generator is, well, we have to realize that it's not truly random. So it's this algorithm that seems random to us, but it's a computer does it, so by definition it's basically not random because the computer can predict what card it's going to pick next. But if we give it a seemingly random input to sort of start this algorithm that the computer is using, and if we don't really know what it is and there's no way to really replicate it, then it's as good as random to us. So what the computer has decided to do is to every time we hit compile, the way we're going to seed this random number generator is it's going to go to the clock on our computer and it's going to pick off the current time, like the seconds in time, or the current time in seconds or something along those lines. And each time we run the computer, it's going to grab our time thought of in seconds, and that's going to be different each time we run the program. So we're always going to be putting in a different input to this program, so we should expect a different and seemingly random output. So here's how we do that. Here's how we pass the random number generator the current time, is we seed, so the command is srand for seed the random number generator. And what are we going to give it? We're going to give it our time, thus the need for this time header, time null, our current time. So seed the random number generator, seed it with the current time, time null. Now if I just do it like this isn't going to have any effect. I'm not going to see anything. But once the random number generator is seeded, I can use the random function, which is just rand. So let's make an integer, which is called random number. And let's say, give me a random number. So the command for that is just rand. It's a function that doesn't take any parameters, rand. But what I want to do is I want to pick a random card to display to the screen. So I don't truly want a random number. I don't want anything from like 0 off to 5 million. I want some number that's in between 0 and 51. Not 52, because I would step off the end of my array. So I want some number in between 0 and 51. So the way I'm going to do that is I'm going to use the mod function. I'm going to take any old random number in the world that my random number generator comes up with, and then what I'm going to do is look at its remainder when I divide by 52. So that's some number in the range of 0 to 51. which is exactly what I want. So instead of actually picking up the deck of cards and shuffling the way that I would in real life to create some randomness, I'm just going to ask for a random number, and then I'll just print, that position in the deck array. And that's as good as shuffling them up and then taking the top card. In fact, it's better because I get to maintain this internal organizational system to my deck, which I like. Helps me code better. So here we go, we pick a random number, and then let's call our printcard function. Printcard. What card do I want to print? The one that's in the deck at position random number. So if I go to the deck at position random number, that'll be an individual card. I'll then pass that card to the printcard function, and it'll get printed to the screen for me. And here's what I'll do. I will run this program 3 or 4 times so we get to see the sort of randomness happening and believe it. So here I'm going to debug my program and run it, and it picked the 9 of hearts. I'm going to run it again, and I got the 3 of clubs. And I run it again, I get the 3 spades this time. Let's do one more time for good measure. 3 of hearts. Oh my, that seems very unrandom. Let's do it again. 3 diamonds. Remember, it's not truly random. It's only pseudo-random. Seemingly, I mean, we know it's working. It is actually giving us different suits. Oh, there we go. King of spades. That makes us feel a lot better. Really is truly picking a number at random and having that effect. So there you have it. This is our general outline of a struct, some of the things that we have to do along with a struct, and just a brief introduction to using this random number generator. What I'm going to do now is I'm going to take this code and comment it up maybe a little bit nicer and put it up on e-learning for you, and you're free to use it in all your programs from this point out.